So it's simple enough. Your teacher says to you, simplify 20 over 24. And you're thinking, psh, I got this. I got like 5 ways I could do this. I've been doing this since I was like, I don't know, 8 years old. But then your brain freezes. Which method should I use? When they say show my work, what should I do? Maybe I just do it. I don't know. So here's 5 ways to do a fraction reduction using 5 different methods. Here we go. Method number 1. Method number 1, we're going to call it the birthday cake method. You take your fraction, 20 over 24, and we're going to find what we call the greatest common factor. This is the shortest way to get right to the answer, but you got to do a little pre-work beforehand. So what I'm going to do is I'm going to take 20 and I'm going to take 24 and I'm going to find the greatest common factor. If I divide them by 2, I get 10 and 12. I know that 2 goes in again, so I get 5 and 6. So I know that if I take these 2 factors over here, I can divide the top by 4 because 2 times 2 is 4. And I can divide the bottom by 4 to get 5 over 6. That's one way. There's a second way. Way number 2. We're going to call it logic, or the logical method. Sometimes you can't get all the way to the end to begin with, but you know that there is something that goes into both. So I'm going to start out again with 20 over 24, and I'm going to say to myself, logically, what goes into both? This is a way to shrink fractions down right away. So I know immediately that 2 goes into both of these. I'll divide by 2 on top and by 2 on bottom. I end up with 10 over 12. But then I look at it and I logically think, well, they're both still even. So I know I'm not in lowest terms. So what I need to do is I need to say to myself, 2 goes into both again. And I end up with 5 over 6. Logically speaking, I look at it and I say, is there something that goes into 5 and 6? Well, no. So my answer is 5/6. Here's a third way. Third way, we're going to call it prime factorization. Prime factorization is a way to shrink it down, also using the factors of all these numbers. What I'm going to do first is I'm going to take 20 and I'm going to take 24 and I'm going to find the prime factorization. If you don't know what that is, I'm going to make a factor tree. 2 times 10, I circle 2 because it's prime. 2 times 5, I circle 2 because it's prime, and I've got 5. So on top, I've got 2 times 2 times 5. That's another way to write 20. I'm going to do the same thing for 24. 2 times 12, I circle 2 because it's prime. 2 times 6, I circle 2 because it's prime. 2 times 3, I circle 2 and 3 because they're both prime. On the bottom, I've got 2 times 2 times 2 times 3. And what I'm going to do now is I'm simply going to cross out things that are the same. And what I'm left with is 5 on top and 2 times 3 on bottom, which is 6. I took out prime factors and that allowed me to reduce my fraction. That only works if you know that the numbers are going to reduce all the way down. So then you need to look at your fraction and say, is there anything that goes into those two? If not, we're done. Number 4. A fourth way to do this, I'm going to call the sunshine method. And you're going to see why in just a second. I'm going to take 20 and I'm going to take 24 this way. Scroll up a little bit, give myself some space. What I'm going to do is I'm going to make the sunshine by writing out all the factors of 20 and 24. So what I did was 1 times 20 is 20. 2 times 10, 4 times 5. Notice I worked from large and small, and then I moved in toward the middle, and when the numbers meet in the middle, I know that I'm done. I'll do the same thing for 24. 1 and 24, 2 and 12, 3 and 8, 4 and 6. And what I'm going to do is I'm going to compare the factors now. Notice, kind of looks like the sun. I'm going to find the biggest one I could possibly find that's shared by both of them. It's not 24, it's not 10, it's not 8, it's not 6, it's right here, it's 4. So then I step off to the side and I say 20 over 24, and I divide by the biggest factor that I could find. Divide by 4 on top, divide by 4 on bottom, I end up with 5 over 6. Notice, kind of like the first method, and I found the greatest common factor in a different way. Works a lot better with smaller numbers. And my fifth way, fifth and final way, I'm going to call it the logical primes method, or logical factors. It's kind of like the prime factorization method. It's kind of like the logic method. You're going to see how it works. I've got 20 over 24. And a lot of times I use this method with really big numbers. Well, what I'm going to say is this is really equal to 2 times 10 over 2 times 12. And when I do that, I took out the factor of 2, so I ended up with 2 or 10 over 12. Well, I can say that that's equal to 2 times 5 over 2 times 6. And you'll see how this is kind of like that other method. And when I get down to the end, I can see that I can't really write it as anything else that's going to have the same factors. And so my answer is 5 over 6. That's 5 ways to reduce fractions. Simplify them up, get them in lowest terms. Thanks for watching. We'll see you next time.